Hello, organizers and Demolition colleagues. My name is Eirik Wraal, and together with Mr. Oyvind Omnes, we are eager and grateful for giving the opportunity to use approximately 25 minutes of your time to share our story about the Murmansk challenge. As mentioned, my name is Eirik Wraal, and I'm the manager for AFDCOM. Mr. Omnes is the project manager for the Murmansk project. Oyvind is going to serve us some interesting highlights from the last 3 challenging years up in the north of Norway. To give you guys a small foundation, I want to use a few seconds to talk about who we are and what we do. AFDCOM is a part of the AF Group. Together with the AF Group's other business units, we share the same goal to be innovative and to address the future. Therefore, the A and F in AF Group. In short terms, our mission is to make everyone happy through continuous growth and value creation. The AF Group is one of the largest contracting and industrial group in Norway. Okay, sorry. We are listed on the stock exchange, and through the stock exchange, the AF Group has many different owners. But a large share of the group is owned by us employees. That's quite important. Today we are approximately 2,400 employees in Norway, Sweden, Poland, China, and the UK. AFDCOM is composed up and around forward-lean colleagues who request new and different thinking. Altogether, offshore and onshore, we are 340 employees who daily recycle industrial plants, shipwrecks, and offshore installations. Simplicity is our main key to take on the most challenging tasks. Our mindset has, until now, led to a yearly turnover of $160 million in the demolition and recycling business. But now, over to our main topic, the removal of the cruiser Murmansk. And first, some background and history. The cruiser was built during the Cold War in 1953 and took part of the mighty Armada in 1955. Murmansk was taken out of operation in 1989. After a few years' rest in Kola Bay, Russia, the cruiser was towed toward Bombay, India. On Christmas Eve, the 24th of December 1994, the Russian cruiser broke free while being towed and particularly sank outside the small village of Sørvær in the north of Norway. Sørvær is located on the north coast of Norway. Norway is a long-winded country, and the distance between Oslo, the capital, and Sørvær is the same as between Oslo and Paris. That mentioned, the removal was not going to be carried out in our everyday neighborhood. Immediately after Murmansk sank outside Sørvær, people was anxious about the cruiser's content. 1 year after, a Norwegian salvage company tried to get Murmansk floating again, but had to abort a mission. Question remained unanswered. Local authorities and organizations proceeded their speculation that it might be hazardous substances and waste on board the cruiser. In 2007, discoveries were made of low-level radioactive components in the wreckage. the media published the result that Murmansk contained radioactive and other hazardous substances. In connection with ongoing parliamentary election campaign, the Minister of Fisheries in Norway ordered Murmansk to be removed. In 2009, the Norwegian Coastal Administration advertised a tender for the removal contract. Over 20 national and international companies registered their interest. AF was commissioned by the Norwegian Coastal Administration to remove the wreck of the former cruiser the same year. The AF method proposed was considered to be the safest according to health and to the environment. Many said and thought that AF's bright method idea was totally crazy. In many ways, I can actually agree upon that. But the idea has given us 3 thrilling years with a lot of challenges and a lot to remember. Now, Mr. Omnes, I'm happy to leave the word to you to tell us about how our mindset and simplicity has worked out in the cold north.
Hello everybody. Our approach to this project was to identify all risk factors and then develop a method for minimize all the risks. The overall task, removing a Russian warship, can seem big and complicated, but when you divide it, it's not that hard. So by looking at the works, we isolated the different tasks in sub-projects and we reduced the risks. The solution was a model in which the work was divided into 4 different projects. You can see the phases here. Phase 1, preparation and construction of breakwaters. The environment and the place itself is it's a hard place to be, so we needed to get some shields and try to cover up the whole site. So we needed to build breakwaters. The phase 2, that's the construction of the dry dock. The idea is to do demolition dry on the seabed, so we needed to construct this dry dock. Phase 3, which is the main phase, was to remove the ship and take all hazardous waste away and remove the steel and everything. We just finished that phase. And the next phase now, that's phase number 4, it's to remove the whole site. Actually, we're going to reuse most of the rock material that we have moved out here to build a new breakwater in the neighbor village on Sørøya, this island up north. I just explained to you about the breakwaters. That's the first phase, and it's very critical because then you have a very virgin landscape to start with. And it has been very challenging to build those breakwaters. But in June 2009, when we got this project, we started preparation for the building, and we moved all our machinery and housing, barracks, and everything up to Sørøya by boat. It's far out on the Norwegian coast, so it's very hard to rig up, but it's possible. We started in July-August 2009, doing blasting in a local quarry. We got permission to extend a local quarry, an old quarry, to build these breakwaters. Here you can see a picture of how we started. We have connected a flat top barge onto the only onshore point to get onto this area. It's just a small island. So that was where we had to start, and we had to make a foundation to start the whole building. We started up with blasting work immediately after the agreement was closed with the local quarry, and then we started this way. Here you can see some progression, and you can say the formation starts to form into a work site and with breakwaters. The top level of the breakwater was built in a normal way by using big dumpers and the level from -4 and up to the top of the breakwaters was built this way. The largest breakwater we have two. We call it the western and the southern breakwater, but the western one is 270,000 cubic meters, dumped with split barges, and then the top is made out from flat top barges. In total, we moved 500,000 cubic meters of rock material to cover it up. So there's a lot of work before you can start demolition, but here you can see how the dry dock is placed onto the ship and how it will form afterwards. Next phase is the construction of the dry dock. It's built in a traditional way with flat sheet piling, but we needed some supportive rock masses to put the sheet piles down in. And we have hammered the sheet piles all the way down to the hard rock on the seabed. And the depth varies a little bit, but in the western part we have depths up to 30 meters. Here you can see the sheet pile parts comes into Sørvær by barge. We have used approximately 2,000 tons of sheet pile wall, and yeah, it's about 10,000 square meters. This is the first sheet piling work done on the site. Here you can see how the sheet pile wall is supported by their own fillings. The breakwaters outside the whole site, and we are trying to close a ring around the ship so we can empty this pool and go down on dry seabed. Next picture gives the whole idea of how it works. The ship itself, it's 211 meters long and weighs approximately 17,000 tons. The depth inside the pool here varies a little bit. In the part in the back of the ship, it's 17 meters down to the seabed sand, but then it's 14 more meters to solid rock. And the ship was put into the sand approximately 7-8 meters. In the front, the depth to the sand was 7-8 meters, so the ship was actually laying like this and was very unstable. And then the main phase started when we had finished the construction work. We started with the main phase, demolition of this wreckage. Our strategy basically is to remove it where it lies. We wouldn't use heavy craning, but just use proven methods, simplicity, by doing this on dry land, so it can be compared to demolishing onshore. The AF method has a lot of advantages, we thought, and reduced a lot of risks, especially the environmental questions. But also we eliminated the risks and uncertainty involved in underwater operations and lifting. We didn't believe in coming under the ship to both hook and do wire saw, because we had 8 meters down into the gravel. So we wanted to see what we were going to demolish first. The method also minimizes the risk with respect to health, safety, and security, we thought, and we still believe in it. We see when we have emptied the dock and done the demolition, we are very happy that we did it our way. It also minimizes the weather limitations during the demolition projects. If we would decide to go in here by big crane ships and heavy lifting, the weather windows are very small. We always have swell in the sea, and it would be hard. We could, of course, use jackups and stuff, but then the depths are a problem. So, after a lot of challenges and a lot of construction work, the site was looking like this. This is the 18th of April this year. Approximately 35,000 cubic meters of water had to be pumped out, and the ship, we saw more and more of the ship every minute. It was a good feeling. And during the first phase of demolition, we did what we call front running, sending people in, removing all hazardous waste, cables, electrical components, do surveys, measurements of radioactive sources. In this case, we had to look for grenades. It was very hard to get into this ship because it's so broken down. It's actually broken into two pieces because of weather and wind during the last 18 years. But we could do we could do some surveys close to the demolition areas, the first demolition areas. So that's what we did, and then also removing of everything that we found and was hazardous. And after this front-running period, we brought in a lot of equipment with shear sawn. It's a heavy steel job, and you need the right equipment. The equipment was brought in by ship. We had in a total 11 excavators with special equipment on it here, and then wheel loaders and dumpers, of course. So 13, 14 machines all the time. The biggest one was this Hitachi 1200 with a 1500 Genesis shear sawn. So after the front running and after bringing in the heavy duty equipment, we started on the structure demolishing. Here you can see the 1200 taking down the barrels of one of the cannons. That cannon weighs 250 ton. It's 155 millimeter projectile. The thickest steel thickness we experienced here, that's in front of the cannon, 17.5 centimeter. So of course that's no job for large equipment either, so then we had a lot of torching to do. And then it's the phase 4. I spoke to you a little bit about it, but we're going to remove the whole site again. So that means we're going to move approximately 100,000 cubic meters of rock material to make this new breakwater in the neighbor village. And we're also going to delete all tracks here. When we leave Sørvær, you can't see that we have been there. So all the sheet piles are going up, of course, and all the mass is going to be put down to contour -5, so you can sail over it. Maybe I make myself misunderstood and that you find this project as a walk in the park, sunny day. That's not true. It can be misunderstood. To be honest, there have been several reasons why we decided to call this presentation the Murmansk Challenge. We have been there for 3 years. We have had a lot of setbacks. We have had enormous challenges, but we've never given up, and we have always been sure to make it. And it's actually like this that we sometimes have started to believe in higher powers. Like this, for instance. This is just after finishing the first breakwater, the western, the one on 270,000 cubic meters. It's 140 meters long, and it's 110 meters wide in the bottom. It's 30 meters deep. The waves outside the molo was 16 meters. And it's impossible to get out there by any kind of equipment or ship trying to save both equipment and construction. Fortunately, this was a storm that only lasted for 24 hours, but it was enough to build up the sea to 16 meters waves, and we lost 50,000 cubic meters of the heavy rocks for the breakwater. And as you can see, the sheet pile wall wasn't quite finished, but we broke down approximately 80 meters in the deepest part of the site, 30 meters deep. This is how it looks from my office on shore. It was impossible to get out there. You can see the flat top barge. It has moved approximately 80 meters, was just hanging on its wires. And you see the construction out there becomes small when these higher powers comes in. This is just outside my office window. My window was underwater several times, so I started to bring some oxygen into the office. To be sure. The village of Sørvær and also all the villages around the Finnmark coast, the northern part of Norway, suffered a lot of damages, and the Nature Disaster Fund, it's an organization in Norway, they had to help out many of the inhabitants because of a lot of damages. We've also had other challenges. Here you can see how it looks inside the ship. It's impossible to get in there. We have found 21 grenades now, and this is the largest one, 155 millimeters. One of 20 has been sharp, but we of course think of all the grenades as sharp, so then we bring in the Norwegian National Defense and they defuse the explosives. Then we can sum up the process a little bit. This is early April this year. The construction itself finished. The pumping hadn't started. We're doing injection and sealing by dense masses. In the area we had the storm damage. But then we started pumping and everybody was happy. The water level went down pretty fast. We pumped the whole dock dry in 4 days. And then we could see what we actually gave a price on for the first time, and we were scared. But it wasn't impossible. Here you can see that's the level of the water when we started, because we didn't want to put more forces onto the construction than more than we needed. So we kept the water level on -10, and then we took out almost 60% of the ship before we lowered the level and took the rest. This is how it became after pumping even more down. A lot of activity, both torching and machine demolition. The combination is a safe winner, but the ship itself, it's a very challenging demolishing work, because you have these enormous steel thicknesses. The sides of the ship, approximately 140 meters of the side, was covered by what we call the belt armored plate for taking torpedoes. It was 10 centimeters, 100 millimeters thick, and 140 meters on each side, and then 3.3 meter high. So when you see that for the first time, you think a lot of work. And it is. This is not many days ago. This is even closer to this day. So now we are finished. The ship is removed from its origin position, and all the materials are moved up to higher levels. A lot of the steel is also shipped out, so we have taken out approximately 7,000 tons, and we have 4,000 or 5,000 tons more to ship out. Then I'll give the microphone to Eirik again.
Thank you, Oyvind. The last phase of the project is currently ongoing, and we are going to carry on during 2013 with the removal. But we can still do some conclusions. We have removed the Murmansk ship in the most environmentally friendly way possible. we have active use of the AF's environmental management systems, with monthly reporting our carbon footprint. We have used the most modern equipment, and we have equipped our excavators with a complementary oil quick system, which helped us a lot. Recycling, that was main focus with the whole project, and the whole project will have a sorting percent better than 96%. I think that we will recycle 100% of the boat itself. We're also going to use or recycle the piles and the breakwaters. Together with a short internal transportation, we are doing it in an efficient way, economically and for the environment. Independent of size and complexity, these factors are and was vital for a sustainable result on this project. We hope that we have given you some interesting glimpse of our project, and hopefully some new creative ideas. So, Oyvind and I, thank you for your time.